Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House podcast.
Hello and welcome back to the Passive House podcast. I'm Matthew Cutler-Welsh, coming to you this week from very sunny Adelaide in Australia. And we're welcomed this week. We've got Zach. Zach, how are you doing?
I'm good. It's cold in Seattle. I'm jealous.
Cold in Seattle. Well, yeah, it's going to get pretty warm here this week, but
maybe I'm not jealous.
Yeah, but it is quite nice. And Mary James, welcome back. How are you?
I'm good. I'm about to face 5 days as atmospheric river heading our way. So I'm not looking forward to that, but hey, we need the rain.
Yeah. And Ilka, great to have you back with us. How are you doing?
Yeah, I'm doing great. I'm glad to be back. And Philly is actually freezing. It's not just cold, it's freezing. But I'm hanging in there. Literally freezing.
Have you had snow in Philadelphia?
Yeah, we had a little bit of snow and it's been laying on the ground for probably the last 2 weeks.
Yeah. All right. Well, good to have both you, Ilka and Mary, as we finish off our conversation that we started last week, which is a fascinating panel discussion about reuse of building materials and looking at deconstruction as opposed to demolition, which is, I think, a really it's a great way to think about taking buildings apart carefully so that we can reuse those materials, and really great to see some examples of that being done in the real world. So some great things to get stuck into for the second part of this interview. But before we do that, Zach, we've got a few people to thank.
Yes, absolutely. So I want to start by thanking our accelerator partner of the week, Buck Moorhead Architect. So a big thank you to Buck and his firm for supporting all of our work here at the accelerator this week. And I also want to give a big thank you to our sponsors. So thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thanks to our founding sponsors, 475 High Performance Building Supply, Ingwe Architecture, Partel, Rockwell North America, and Zola Windows. And thanks to our champion sponsors, Bewizo, Cascadia Windows and Doors, European Architectural Supply, Thacro, Icon Windows and Doors, Intelligent Membranes, and Source 2050.
Great. All right. Now, Ilka, just remind us how this panel came to be, and where do we pick up on this episode?
Yeah, so I actually saw this panel speak at Greenbuild here in Philadelphia in the fall, and yeah, it was just a really, really interesting presentation and panel discussion. And what I really liked about it is that you really got the understanding that deconstruction is not something that's just theoretical anymore. It's actually something that is happening also here in the US and not just in Europe or in New Zealand or wherever, it's coming from. So yeah, I thought that was a really, really good presentation, and I wanted to really talk to them a little bit more. And in the first episode, we focused a little bit more on the bigger picture of deconstruction. And here in the second episode, it's a little bit more about the nuts and bolts of how to do it. And Imani is actually the one who put this panel together, and she is doing a little bit of a recap from the first episode in the beginning of this one.
Awesome. All right, well, let's jump straight into that discussion. And here is Imani with a bit of a introduction, as you said, Ilka.
in this first section, Katrina and I think both were able to introduce our personal experience working from the design and structural engineering perspective and how Ramboll has participated in deconstruction and material reuse projects, research studies, etc. I think part of putting this panel together was also about, as you mentioned, deconstruction requires an ecosystem, right? And there are many, as does the circular economy. It's the economy side of circular economy, requires collaboration and coordination between many of the various aspects of a building process, right? Including many different trades and services and businesses that kind of complete that circular economy and help us complete that circle for these materials. So I think Eric and his technologies are a really awesome and very fundamentally important sort of prerequisite to material reuse of some of this timber in order to separate the metal components from that timber, right? Until they had figured that out, that's been a hurdle for many people. And I know Megan and Holmes have been really at the forefront of looking at how we again put together buildings so we can take them apart. So I hope you all enjoy hearing from them as well. And we look forward to continuing the conversation too.
Perfect. Thank you so much. Megan, you are a structural engineer with Holmes. And what's interesting about the structural engineering in relationship to deconstruction or reusing materials, in my experience, a lot of times it's the structural engineers that are very reluctant in allowing to reuse structural elements. So what is your perspective and how come that you are basically trying to do the opposite?
Yeah, I will take full responsibility for our profession. I'm kidding. I think why there's a bit of concern is just that there's a bit of stigma around reusing existing materials, whether that's from the general public or from the structural engineering profession. I think that just really comes down to what we've said in the previous episode was really around just understanding what that existing material is and wanting to feel confident in its properties, that it's going to be durable and live up to the structural integrity that's required for the building. So I do think that's a little bit why you see some of that hesitancy. I will say, in general, engineers can get a bad rap of being resistant to change, and maybe that's a good transition into kind of where I'm at and my firm at Holmes. We are a company that embraces innovation and isn't afraid to take risk. And I think being founded from New Zealand in the 1950s and kind of expanding into the US over 20 years ago, I think having the kind of New Zealand background has just kind of led to that collaborative and risk-taking environment. And I think it has been that mindset that's really empowered our firm to kind of push boundaries across using different materials, technologies, and really being able to see sustainability initiatives really push forward in projects. I think one big thing that I've been trying to focus on in my career is how do we really implement practical solutions that we can see get built, because I feel like there's a lot of times a lot of just talk around sustainability and what we can really do, and then nothing at the end of the day, nothing gets implemented into practice. And so I've been really trying to focus on what are those cost competitive strategies that can get implemented, that whether or not your project has sustainability goals or not, you can still be making a difference. I think, I definitely got to experience that firsthand in my career, working on some of the first mass timber buildings in California, for example. And I think it has been our firm's just culture and being early adopters of mass timber that has really opened a lot of doors to push the boundary in not just timber construction, but also in sustainability strategies like design for deconstruction.
Megan, can you give us some examples of that? It sounds so great in theory, but as you said, let's see it in actual practice. So it'd be great to hear more about that.
Yeah, so I will kind of maybe build off of my experience. I've really focused a lot of my career working for a lot of large technology companies. And I say that because it's just allowed us to kind of push the boundaries, I guess, in a little bit different ways than other structural firms or structural engineers working on different types of projects. And I think in that, those clients have really wanted to push the boundary to really attract the best talent to come work for them. And so being able to get involved really early on with mass timber in the state of California, mainly because it was aesthetically very pleasing, and it just offered a lot of low carbon benefits. And talking about timber, why that's important is I do think it's been just some advances we've seen in the engineered lumber products, and being able to design buildings and think about them very differently than we have before. I think the design for deconstruction has been a challenge, particularly where I practice in high seismic regions, because when you usually think about needing to deconstruct a building at the end of life, it's hard in that, you know, being able to transfer high seismic forces around a building just requires a lot of more robust types of connections. So that usually meant cast in place concrete and welded joints and welded connections. And so with kind of this insurgence of new engineered lumber products and mass timber, we've just been starting to see and be able to implement just some and push the boundary on different sustainable strategies. And so we have been involved in a couple projects of late, all mass timber examples, but one of which we were working with a developer to look at how do you bring on a large amount of residential units in the Bay Area? How do we leverage the pre-manufactured nature of mass timber? And so we were tasked with really thinking about how do we build buildings differently, more efficiently with larger pieces, coming to the site with the structure, MEP, and architecture already kind of integrated. And in addition to thinking about the most efficient structural system, that project also wanted to look at and dial in on the current mass timber connectors on the market. And so we also had performed some time and motion studies on the current connectors available, and then re-engineered them to take into account installation time, deformation compatibility, that they could achieve the required fire ratings, be self-propping during construction so that no temporary shoring of your columns, for example, during construction would be required. And the other big main criteria for this endeavor was that these connections could be fully disassembled. And so while the residential units of that project is a bit on hold right now, that connection technology is being brought to the market later this year with Hilti, and we do have some of the first connectors being put into pilot projects and being installed as we speak. Maybe then another example that we've been seeing of late for kind of a mass timber, a design for deconstruction project at scale. We have worked for a tech client that really wanted to target deconstruction from the start. The project was already going to be mass timber, and kind of this concept or idea of being able to disassemble the building at the end of life and be able to reuse it just really resonated with that client. And I'm not saying it was an easy process to be able to do, but I do think one of the reasons why that project stayed and was built to be fully deconstructible was that it was just a driver from the start. We specifically for that project were able to achieve a fully what we call a dry system, so no cast in place concrete above the foundation level. And so we were able to just rely on like a different type of floor build-up assembly that had cement boards that allowed the system to meet the acoustic and vibration requirements for the project with no cast in place concrete. And then for the lateral system, which is one of the bigger challenges, we were able to utilize just fully bolted connections, so not having to have any welding done on site, and then relying on a lot of screws and straps and plates to kind of transfer all that lateral load around that building. And then I think the last bit is just into the connections and how does the building get put together. I think the other big key is you really need to look at all of the different conditions and really do a lot of pre-coordination to make sure that these buildings can come together really efficiently, so that everything can be either screwed down or bolted down into place in construction. And that also does have benefits from a speed of construction that I think doesn't necessarily get built into a cost estimate early on in a project. But I think we're seeing a lot more push for these types of strategies being built into projects as just, embodied carbon's been just more front and center of everyone's mind.
So you just brought up the topic of speed of construction and how that relates also to deconstruction, because the connections are built to be basically constructed, but also deconstructed quickly, right? So I find that very interesting, because I think in one of the case studies, I think we also saw that deconstruction most likely takes longer than demolition, or so far it's always been taking longer, and that can be a little bit of a hurdle as well, people shying away from deconstruction. So I think what you just brought up, just thinking ahead, to the deconstruction part, also benefiting the construction part, if you look at panelization, right, as well, like big pieces, not just little pieces. So I find that very interesting.
And I think speed of construction also is dollar signs, right? That's enormous savings in some cases for projects. So I think that's another thing that owners or developers would be really interested in, right? The ability to put it all together more quickly, as a result of these kinds of connections, like what Holmes has been developing.
Yeah, being able to eliminate on-site welding, I think, is huge. Being able to eliminate the need to, provide temporary shoring to your structure before the full structure is put into place to lock it all in place. I think these things are really going to, be game changers in construction.
It brings up for me the question of size of a project. Like, is there an ideal size for designing for deconstruction, or does it not matter?
I don't think it matters size-wise. I think it would be, how do we be smart about limiting the unique conditions and cases that you have to design, or Eric would have to detail for, I think would be the more thing that you'd want to look at. And I think mass timber in general just lends itself, because it's panelized, lends itself to that kind of thinking. I think being really smart about the grid and the dimensions, and how do you replicate, the same thing over and over again. I think you'll see more, I don't know, economies of scale in that sense. But I don't know if Katrina or Imani, you had thoughts on size.
I agree.
Same.
Yep.
Part of the question about size relates also to, residential. It seems like the case studies that you brought up they're larger projects. And I mean, I guess that's logical, because it's the larger projects where there's probably going to be more cost savings looking into it, as opposed to a single family home. Would that be correct?
For initially, right? For initial R&D, if you've got to do some R&D costs, spreading it over a $20 million office building is going to go way better than over a $500,000 home.
That said, the deconstruction requirements are actually in the US more specific to residential buildings than they are larger ones. So the drivers are different. I think that's why we're not necessarily leaning towards a size piece, but you're absolutely right, Eric. Like, the budgets can sometimes support some of these additional, the cost of doing something newer.
And I think also the practical deconstruction of a larger kind of commercial building would be more complex than a smaller single family home. So in terms of actually deconstructing a larger building, like, it would require more. But I think also Eric can probably talk more to that.
We love warehouses. Warehouses are way easier to bring down. It's almost the same price and time to deconstruct a warehouse as it is to demolish it.
Well, great, because I mean, there's a lot of warehouses in the world.
There are.
That's interesting. Can you elaborate on that?
They don't have any interior partition walls or demising walls, right? They're just big open buildings with big beams and big trusses. So it's very easy to use existing demolition equipment today to bring those buildings down. They have typically large framing members, right? If you compare recovering a 2x4 to a 4x12, an excavator can recover a 4x12 very effectively. They cannot recover 2x4s. And so when you get into small buildings, take a multi-family apartment building, for example, you got lots of small walls, lots of small framing, a lot of labor is involved in taking those walls apart, and you can't do it with a machine. Whereas a big open span warehouse, you can get a couple machines, a couple operators in there, and they can bring it down very quickly and load the material onto trucks. And that's kind of to the point of, we are in our infancy today on tooling for deconstruction. That's why it's typically costs more and takes longer to do it, because it's still very laborious, with the exception of warehouses. But if we go into office buildings, we go into multifamily apartment buildings, those buildings are requiring large labor forces with really a lot of hand tools. It's pry bars and hammers, and we have not developed the tooling to help those crews. And so that's some of the things that we're working on with some partners. And then what do you do with those materials, right? How do you get those materials ready for reuse? Because when you look at the core components of the structure, either wood, steel, or concrete, you can't just take down a building and suddenly, hey, here's your raw material, right? Like concrete has to be ground up typically into base rock, and then mixed again and processed and reused in its next structure. Steel or concrete slabs, we're going to have to be cut up and sized and trucked to that other project. Same thing with steel, right? You got to cut it up and you got to turn it into pieces for the next one. And we're focusing on lumber, where we cut it, where we remove the metal fasteners so it can be processed and turned into its next finished product, ready to go into a building. And those are all supply chains to be developed, right? They're all still in their infancy, because historically it's grind everything up, concrete, steel, wood, separate it, and then turn it into new products or downcycle it into whatever it may be. Wood's example, it's typically fuel or landfill. Concrete's base rock.
So, and Eric, you developed some new technologies, right? Can you tell us a little bit more about Urban Machine?
Yeah. So we're a 3.5-year-old robotics company, where we've developed a machine that automatically removes the metal fasteners from wood so it can be used again. Right now, there's two things really preventing the reuse of lumber. One is deconstruction. In order to get the highest quality and highest volume, you want to deconstruct a building. And then the second piece is getting all the metal out. Because with metal on the wood, you can't plane it, you can't cut it with traditional wood processing tools. So that prevents large scale use, right? We can't run it through a mill and generate 100,000 2x4s to go into a CLT panel until you get all the metal out. And so that's where we come into play. So we are automating that process to bring down the cost of reclaiming lumber. The goal is to reclaim lumber at a price parity with virgin lumber. So there's no longer a cost premium when you say, hey, I want to use reclaimed lumber for my mass timber building. Excellent. It's a choice and the prices are the same.
And from the engineering perspective, is the reclaimed lumber that you sell, is that comparable with new lumber?
It's typically higher quality. Modulus elasticity changes a little bit because it gets a little harder with age. But in general, the older the material, the tighter the grain. So it's higher strength material typically is what you find. Today's trees are very short lifespan. They're grown very quickly on tree farms, and they don't have the same quality as a tree that was harvested, 50 to 100 plus years ago. And so we're in the rare instance where our reclaimed product or recycled product is actually higher quality than the virgin product you can purchase today, which is incredibly unique.
And what I also thought was really interesting, and you mentioned that in the presentation, is that your lumber actually becomes or is FSC certified? How does that work?
So FSC has a chain of custody certification for reclaimed products. And so we achieve certification because we track the source of our material. Either we get our material directly from the building site, where we work with the deconstruction contractors or the demo contractors to source it, or we source it from the waste facilities. And so it's all post-consumer recovered product that's been diverted from either landfills or incinerators. And so FSC provides a certification process that we follow for that.
And do you sell this lumber? I mean, you mentioned selling it. So where is it available if somebody was interested? I mean, would you just go on your website?
Yeah, so we actually have our inventory on our website. We're based out of Northern California here. Our yard is up next to Napa and American Canyon is where our machine operates. And so, yeah, we are currently in the lumber business. Long term, we want to be in the robotics business. But when you want to do something new, you can't just build the technology. You also have to prove the business model as well to go with it. And so we work with architects and engineers and contractors to specify reclaimed lumber back into projects. And we're working on some case studies from some of those projects as well.
So do you ever have issues like sourcing the materials? As we talked about, just demolition is easier and is faster than deconstruction. So who wants to keep everything intact to deliver it to you versus just, tearing everything down?
Yeah, so what's interesting is we thought, most of the material was going to come from demolition. But what we learned when we were working with the waste facilities is a lot of wood is just used for temp structures. A lot of wood is handrails. A lot of wood is scaffolding, temporary walls, formwork. If you look at concrete, for example, a lot of lumber comes out of formwork. And that is all long, straight, high quality material where they keep it long to move it on and off the job site. So they're not hauling small pieces. And so what we were finding is massive truckloads of this material was going to the waste facilities and getting ground up. And so we didn't have to rely on the toothpicks from the demolition material. Also in renovations, they're not bringing in excavators, right? They're doing select demo where they're taking out specific walls or they're taking out roof systems. And so the excavators aren't on site to smash everything up. And so there's a large volume of material available for recovery. We did some tests where we could pull a couple tons of high quality dimensional lumber off of a tipping floor within a matter of hours. It's staggering how much high quality recoverable material we send to the landfills or the incinerators.
I guess the question about being able to scale this is a clear yes.
Yep. Definitely from the raw material side, the technology side. Absolutely.
Awesome.
Yes, I mean, I was wondering, are you actively trying to find partners to scale it at this time?
We are. Yep.
And also, I mean, just to be very topical, because if you're located in Northern California, of course, there's been big fires in Northern California, and there's a big fire right now in LA. Is there any possibility of like recovering from partially burned structures?
Partial, yeah. I mean, if there's any dimensionally intact lumber in it, if say only a section of the house burned down and they're going to take down the other section due to water damage or smoke damage or whatever, absolutely, that can be deconstructed and recovered. Unfortunately, what we're seeing today is some of these fires are so hot, there's nothing left except for foundations and chimneys on a lot of these structures.
One thing that's also really interesting, Eric, is your model for growth, right? Like talking about where we are today in 2025 versus the 2050 vision. Right now, you have the urban machine in Northern California, but it might be interesting to talk some about how you see it growing to be kind of these regional assets.
Yeah, our goal is to have machines in every major metropolitan area. So you can source the material locally, which is where all the building stock is, or the majority of it is, clean it up, process it, and then supply it back into that local metro. If you compare that to the virgin supply chain where lumber for North America, most of it comes out of the Pacific Northwest or the Southeast for buildings, there's a long transportation footprint in that material going from the forest to the mills to distribution before it actually ends up at the building site. And so our goal is to get it all localized where you have local raw material, local processing, and then back in that environment. And this essentially secures that product from supply chain disruptions, from the risk of trucking costs, fuel costs, makes it actually a much more reliable, cost-stable product compared to virgin materials.
So it seems like CLT is a really good start to basically look towards building for deconstruction, and reusing lumber is a very good approach to use what's already there. What else? It's such a big field. There's so much more in all these buildings. What else? What's next? Like, what technologies do you see need to get developed to use other materials, building materials as well? Or, how should we build in the future to not only rely on CLT, but, other building components to be deconstructible as well?
I mean, one thing I'll just point out is like low-hanging fruit in the near term. So one of the things we talk about is a basic approach some companies could take is, for example, taking deconstructed concrete slabs, for example, that become crushed and using that aggregate in the landscape, right? Landscape designs often need some level of aggregate. So that's a really pretty easy low-hanging fruit starting place. And I think the other point about deconstruction is it's not necessarily about brick by brick taking every single thing apart, right? As people can picture the ballooning costs and time of that. It's about focus. And to Katrina's point earlier, the focusing on those materials where you have the ability to deconstruct it, but also there's a market for those materials. So I think that's something that we've been learning on a lot of projects too, is how and where to focus based on the local context, on the project and the owner and their intentions and more.
One thing I'll just add that's a little different is something, Imani, you had brought up earlier around technology and, you know, digital twins and RFID chips on products. I think from a structural standpoint, if we can better understand and utilize technology to understand what's in new buildings or what's in a current building, and whether that's, you know, being able to scan a QR code and understand where that beam or column came from, what's its capacity, what's its material strength, I think could help push this forward, in addition to just new material advancements and construction techniques, et cetera, that I think we've yet to see.
I can add one very specific thing that we've seen a lot of success with reusing in Scandinavia. It's brick. So a lot of the older brick buildings have been built with lime mortar instead of cement. So it's more easy to separate and salvage. So they've had or developed a very kind of streamlined also process for that. So they had their own kind of technique with cleaning them, kind of like it's shaking the lime mortar off in a very like effective way. So they're harvesting, cleaning them, and then selling them. So there's a company kind of, I wouldn't say it's similar to Urban Machine, but the concept is similar. So they're salvaging and then selling the new materials. So focusing on kind of the lime mortar. The cement mortar is harder, of course, to separate as it's much stronger. And also just the fun fact for the reused bricks, their process is also so streamlined. So they've also developed their own EPD, or environmental product declaration, for their product. So they already have like all the data for like the electricity and everything that it costs to actually go through that whole process. So brick is another one that's also like the embodied carbon savings are big, and you can use it well in a new construction as well. And then also another thing that we're also working on in Ramboll is cross-laminated secondary timber. So it's a project in London where it's a PhD project, and they've been working on salvaging a lot of timber in existing structures and developing a new product, so secondary CLT. And I actually also believe Eric has spoken to the person driving this project, because one of their main one of their main challenges was actually nails and metals in the timber. So it all kind of like comes back around where a technology like Urban Machine is developing can actually help, you know, solving that one main problem that we're having in our kind of work. So also like just highlighting kind of the importance of these partnerships and conversations we're having and collaborations.
Eric, I remember, I think in the presentation, you actually talked about using your lumber for cross-laminated timber. Is that correct?
We are working with some firms in a couple mass timber products. We're doing, so we're actually producing Dow laminated timber products with All Bay Mill and Lumber, the yard that we're at currently. And then we've spoken with some of the CLT folks who have done some testing and research on using reclaimed lumber for CLT.
a really great call to action, Eric, that you also have is for designers. And I feel like this in some ways is a good point of there's some basic changes that I think your audience might want to consider where they work or operate that actually can help in this process of driving deconstruction to be the future.
That's a really good closure to this interview. What is your call for action? If everyone can just kind of name one for our audience.
That is update your specifications and remove the all materials must be new. That has got to go.
Then I would include including deconstruction as also as part of your specs for deconstruction or for demolition. Yeah. And also just we need to develop these standards for integrating structural materials in new designs.
I'll add, don't be afraid to try something new. Be willing to go out on the limb and take some chances. There's a lot of really great experts out there that you can call upon and ask for, how did you go about doing this? This is a challenge I'm seeing, but I think don't be afraid to really have that discussion about that existing building. Do we really need to tear it down? If we do, can we reuse the materials in the building as best as we can?
Yeah, I would plus one on that I think hopefully in this conversation we've demonstrated that deconstruction is not a concept. It's something that's in practice, in action, applied in projects in the EU, here in the US, as you've heard. And so it's not a question anymore. It's more of how might it apply to this project. So making sure, as Megan said, to take the opportunity to actually ask that question first. Is deconstruction or material reuse relevant in this project? And Megan, I would say include us in that list of experts, right? We should hopefully have our contact information associated with this podcast recording, and we'd love to hear from anyone who's interested in implementing or scaling any of these solutions. So I think, yeah, we look forward to hearing from you and continuing the conversation more.
What a great note to end on. That's really perfect. It's been so inspiring to talk about the reality of deconstruction rather than deconstruction as a theoretical concept.
Yeah, and I think that was my takeaway when I saw your presentation as well. And that's why I really wanted to talk to you more, because I feel like it's still been, or deconstruction is still this kind of vague topic a little bit, and just hearing and seeing what you are actually doing is very inspiring. And I hope that a lot more people are, I would say brave enough, but I don't even want to say brave, it's just what you should do. I mean, it needs to, as you said, it's the future. It has to happen because we just don't have enough resources. So we better get starting on deconstruction. Thank you so much.
Thanks.
Thank
Thank you guys
us.
very much for having us.
Yeah.
Ilka, do you want to start out when we going?
Sure. So I think what stood out for me is really just looking at what it really means in terms of the engineering and also reclaiming the wood. But first, let's talk about the engineering, just what it takes to really think about not only constructing, but also deconstructing the pieces. How Megan talks about even looking at connections that have to hold up in seismic regions, for example. So things that you would usually do just, as a regular, on a regular building, you can't really do when you think ahead and think about deconstruction. So it makes it a little bit more complicated, of course, but once you really work through it, it's going to be available. I mean, she said that some of the connections are available now through or with Hilti, and they're brought to the market. So now others can benefit from that whole development of these new approaches as well. So I thought that was great to hear.
Yeah, that was a really interesting point about the connections being the critical parts, where you think of concrete and steel, it's all about the bits that hold that together, and thinking about how you reconnect pieces of timber, and whether it's engineered timber, it all comes down to the connections, because that's the hard bit, where you're often joining different materials and different products together, that either make it easier or very, very difficult to take things apart again. So yeah, really great to hear people like Hilti are working on that for good system solutions. Mary, what were the highlights for you?
Well, I really loved hearing from Eric, because I love the nitty-gritty of somebody who's developed a business model around trying to reclaim wood. And I love that he said we're in the rare instance where our reclaimed product is actually a higher quality than the virgin product.
Yes, yeah.
Which, that's what a concept. And yet, it's true. You hear carpenters saying that all the time, that today's wood just doesn't hold up like older wood does.
Yeah, an interesting point about I think you mentioned that the older timber can be a bit more, it's not as flexible, it's not as bendy, which may have some implications around the engineering design, but it's certainly a lot stronger. And I tend to think, well, the assumption is that older material is a lot more inconsistent, but in some ways that old grain wood is going to have more consistency, because some of the stuff that we grow, the pine trees that we grow, they're so full of knots, and they're bendy, and so yeah, that's a really good point, that the older timber that can be reclaimed is often of higher quality than what's newly grown, and also can be more consistent, which I think that's the bit that the structural engineers are concerned about, is that consistency. Zach, have you, in your building experience, have you ever had the chance to work with reclaimed material?
Well, in my personal buildings experience, which is very limited, no. But at Hammer in Hand, lots of my colleagues who were in the field, doing remodels and things, were telling exactly those stories, Mary, of just how much better the lumber was and the timber was in existing projects, and just how precious that wood is. So if Urban Machine can bring that cost down to cost parity with new timber and new lumber, then that would be, I would think that would be a real game changer, and super exciting. So it's cool that vision is very powerful, and it's fun to imagine, robotics being able to come in and make this possible. I was really struck. I mean, it's, in hindsight, it's off. I guess it's obvious, but I was really struck by the fact that the tooling for deconstruction is in its infancy. That concept, that there. So really, it's about hand tools, and so if you can figure out how to bring in industrial processes to make this work, then it starts to really change the game. So Urban Machine seems really cool.
Definitely. So I'm having a look at the Urban Machine website, which I encourage people to have a look at. It's urbanmachine.build. And Ilka, I'm not sure if you got any details, but is it a mobile facility? Like, do they take their plant to the site, or are they in a specific location? Do you know anything about how that works?
As far as I understand, is that they are in a specific location, but the goal is, the future planning is to have a lot of those locations, so that you can actually be very localized, right? Just kind of take in the material from very local deconstruction sites, and then kind of source locally as well.
Yeah.
So I think that's the plan. I don't I don't know how big the facility is, if it would be possible to move it at all, or the machine. So I'm not sure.
The video, and yeah, do check out the video. But I mean, it looks like a tunnel house where you sort of old timber goes in one end, and out the other comes this beautiful stack of of reconditioned, denailed, beautiful timber, which looks pretty fantastic, and I could definitely see that being set up on a larger building site. Speaking of large versus small, I thought that was a really interesting point Eric was making about how easy it is to take down warehouses and larger buildings, and the fact that heavy machinery is not very good at picking apart the smaller pieces of timber, which I hadn't really thought of. But that's obviously another challenge, is to scale that down to smaller residential buildings, where it is going to be probably more of a manual process at this stage. But who knows, what sort of technology be available for doing it at different scales. Couple of things that really stood out for me, and I think are really exciting, are the certifications available. The fact that I would never have even thought about an EPD for reclaimed material, nor would I have thought about FSC, because a Forest Stewardship Council, of course, I think about a forest, and the ability to have a certification of that chain of command that Eric talked about is a bit of a game changer when people are looking at green buildings, because they're often looking at these third-party certifications for if they're doing LEED or some other sort of green building certification. Those are really, really important, and they just add to that value of not just the physical product, but also those other environmental credentials of the material. So that's a pretty significant achievement of something like Urban Machine, and that the whole industry to be able to essentially recertify old material. So I'm super excited about that. All right. Any other? Have we missed anything? Any closing comments from all of that?
Well, I was really struck by just the idea of, like, people are conscious of single-use plastics, but they don't think of, for instance, in the same way, single-use wood. Why would you use that? And yet I think there's a mindset, but they talked about a lot of wood is just wasted because it's used once for scaffolding or story poles or temporary walls. And I think that's really interesting, is to kind of change our mindset about, we don't have to use it just once.
Yeah, definitely.
Yeah, and I think for me, it was also thinking about what we can do right now to make it, more usable in the future. And what Megan was saying as well is that understanding the building and what's in there is really important as well, to be able to reuse the material. So what we can do right now, especially with buildings, mass timber buildings, is to log those, right? They have basically a digital twin already. So why wouldn't you save that somewhere for the future of, the end of the life cycle, and then exactly what is in the building and how you can reuse it basically before you even deconstruct it. So she was talking about even having like QR codes somewhere. So yeah, maybe there is a place where you actually burn in a little QR code, and then when it's time, you just scan it and you have access to all that information. So again, I think it's a little bit of a shift of mindset or thinking ahead. And I just think this discussion is just so important and so interesting.
Yeah, it's very cool seeing that combination of the old and the very, very new, and figuring out how to use advanced new technology to make use of old stuff that's old now, that's already old, but also looking at stuff that will become old, and then how do we reuse it at its end of its current life. Awesome stuff. Hey, well, thank you very much, Ilka, for making that happen. Still quite jealous of not being at Greenbuild, but fantastic event, and really great that you could bring us some of those highlights from that, including this really important discussion. So great stuff.